Hello, folks. Going to go ahead and get started. We're going to talk about lubrication system, the engine lubrication system, what we're going to talk about. So when we're talking about the lubrication system is how does the oil get moved around to lubricate. So we learned in the last segment about engine oil, how important it is to put the right stuff in, the right amount in, and change up at the prescribed intervals by the manufacturer, or better, one of the things I do is I go a little bit beyond, and I consider this as actual insurance, you might say. My oil I use in my Ionic, I could actually, I'm going to go ahead and share this with us. I actually can change it, every 7,500 miles, maybe every um, 1,000 miles like that. I change my engine oil every 3,000 miles. It's just a little excessive, maybe to some people, but it ensures that the lubrication gets to where it needs to be. I'm an old school. It used to be, 3,000 miles. Pay me now, pay me later. It was an old commercial that used to be out all the time. But anyways, I'm kind of wanted to talk a little about the lubrication system. Now, how does it get to lubricate all these parts as we go along? So one of the things I wanted to share with you is what happens. Now, when oil is being used and it gets put into different spots of the car, let's say we have a picture right now on the screen, and it shows one stationary surface, and maybe we're talking about the crankshaft. And that crankshaft's got to rotate. It goes around. Well, to keep it slipping, okay, so that slipping part, we want to make sure it's lubricated. If we don't have it lubricated, then you're going to have surface on surface area. And then when we have surface on surface area, like two metal pieces just rubbing against each other, after a while we get heat, and then we get fatigue, and then the metal starts, wearing, and then we start having failure. So we don't want that. We want a good slipping action going on. So these oil molecules that we have up here are what keeps that cushion, keeps that slipping motion going, keeps it from rubbing metal to metal. Is what we got going on. Okay, and then when we do this, it's not a, let's say, a perfect, world, and it's not going to be perfect. We have kind of a wedging action going on. So as we spin, like on this next slide, you see spin, it kind of twisted into that one side over there. And that one side is going to maybe be a little bit thinner, but we still have oil there. We still have that cushion. And you can imagine with the pistons being forced down when it actually, and you can actually see some marks on it when you take the main bearings loose out, and the kind of inspecting, you can actually see where it just gets that little bit. But that actual oil helps cushion that a little bit. So this oil bearing here on this video, this almost looks like a camshaft that has actually got this bearing around it, and you see how the oil feed going around it, and it spins, and what happens, that wedging action going on. So your oil pressure gauges, sometimes you have a light, sometimes you have a gauge. You need to really know what is good and what is bad. Now, depending on how hot it is, the oil pressure might be lower. And now what I mean is the engine temperature, not the temperature outside. I'm talking about the temperature in the engine itself. The oil pressure might be down a little bit. But as it cools off or you accelerate, if it's a colder temperature, you might see it up a little bit. It just depends on what the engine temperature is and also what the engine speed is. As you accelerate, you're going to see the oil pressure go up a little bit. But we don't want too much oil pressure. We'll talk about the relief valve in just a minute here. So some of the different types of oil pumps, this one is actually driven off a camshaft. And this camshaft is actually what drives that gear set. So this gear spinning like that in oil can actually push pressure. And how that does it is on this slide right here, where we're actually taking and moving the oil. So as we spin these two gears, it's going to collect some of the oil and actually force it on through the outlet. So here's my inlet and here's my outlet. And that's how it does on this particular one. This particular one here is a different one. This is actually one of the ones that are very common in some of the four cylinders. My 4Runner actually has this type of setup itself. And it's right on the crankshaft. It's driven right off the crankshaft. There's a little gear kind of right here, these little slots here. Can kind of go into the crankshaft, where the crankshaft machine for this, and that will actually spin this gear. So we have an inlet and then we have an outlet. So that as it goes across, it's going to pick up and squish and move all this oil around, causing it actually to um, pump the oil through, pressurize it as we go along. Another type is this one here. This is a rotor type, and as it spins around, you can see where it picks it up on the inlet here, and as it goes around, it kind of pressurizes it, and then it goes out the outlet on the side here also. Kind of a G-rotor type. This one actually is, similar, but as you see, this walks around. This is driven off the crankshaft here too. As it walks this guy around, it actually causes the oil to move in and out. Actually, an inlet to an outlet as we go along. We do not want too much oil pressure. More is not always better, and this is one of the things that protect the engine. If you get too much pressure, it's going to cause it to squish oil out and possibly cause some engine damage. So we have a relief valve. After it gets up to a certain amount of pressure, that spring cannot hold back that pressure anymore, and it goes into a relief valve setting to where it actually relieves the pressure and bypasses it on through. And you can see this actually not non-relief, this calibrated spring here, and it actually builds up so much pressure that it actually relieves itself. Actually stay right here and here. All right, so here is a typical, how an engine lubrication, and this is how we, we have. Whoops, no, I need to go back one. I got ahead of myself. Okay, so here we have to where we go from the oil pop pickup here, and then we got the oil pump up the front on this particular one, and it actually forces oil across these. There's some bearing areas on the crankshaft, and then we have an oil galley and going up, and then we could have oil coming down, oil going up, feeding all this, and then we have drain backs going here down into oil pan. If you look through the oil filter, here's my oil pickup going through my pump, going through my actual filter here, okay, and then we go up through the camshaft here up to the through push rods up to the rockers, lubricating all this, and then we have some drain back coming down, and we're lubricating these bearings, the crankshaft, and we're actually lubricating the sidewalls of the pistons here also. This is kind of wore. You can wore out rotor assembly. You can actually see a chunk taken out of it right here, and then this actually plate here has been worn from surface. It's not something that's wasn't an amount of time. It just after a period of time this wears. In a lot of the systems, that the oil pump is part of the front cover of the engine, and instead of replacing the whole front cover, if you can get away with it, we'll change the rotor piece and the plate, or rotor pieces, I should say, and the plate, and we'll get oil pressure back up to where it's factory set. The next thing here is, unfortunate. This is really a pump that's wore out. The oil was probably pretty contaminated too. You can see all the debris that's on the screen. This is the screen. Screen goes all the way around. They just have an opening here, and this is really got some sad things going on. This is going to be an oil pump and the screen assembly replaced. Now this is what a normal oil drive looks like, and it looks like they took this out of this particular setup. This would go, drive would go down into here, going up to the camshaft area, and this one actually is in pretty sad shape. This one's in good shape. This one's in sad shape. It actually, the oil pump froze and actually twisted and broke. See, it's supposed to be the same length. This actually broke probably down in the lower area right here, where it actually twisted off. This is another setup here. This is in using an intermediate shaft on this particular one, but to actually drive the oil pump here. And this is just, this is the oil pump shaft here. So instead of having just a camshaft and a crankshaft, you actually have that. Sometimes they call it balance shaft, but sometimes it's an intermediate shaft right here. So this is what drives the pump, and then it pumps the oil through, going up through the different channels up and lubricating all the parts and pieces. And here's showing the journal as it's actually fed, and that crank camshaft can actually be spun. One of the things, we put the oil up where it needs to go, but we need to get it back down to the pan. Then we go through the whole oil filtering process all over again. So we'll have oil drain back, or drain holes that actually drain it right back down into the pan, and then we start the whole process all over again. Here is an oil pan. It's been removed. Actually, it's a brand new one here. And you're going to see this little tray right here. This helps keep it from foaming up. When the crankshaft is spinning around inside there and you got the rods going up and down, it can foam up the oil. If we allow that to be fully immersed up, and we actually had the oil being kind of turned, you might say, or sometimes called churned. When you're like churning butter like that, it can actually cause it to foam. We do not want oil to be aerated. If it's aerated, it doesn't lubricate as well, and that we can cause failures as we go along. So one, you don't want to have too low of oil. You don't want to have too much oil, because it could actually churn. Too low, the oil pickup will pick up air, and then you have air going through the system instead of oil itself. This is how some of the Corvettes set their stuff up. You notice here, mine down the oil pan here, and this one actually has the pickup going through, and then we have an oil tank here, and here we have actually going across here. Then we go through our relief valve going across, giving filter up to the cooler, up to the bearings, and up to the actual lifter area as we go along. This is going to be a push rod type motor system as we go along. So here, my oil pickup going through my oil pump, and then here's my relief valve here across, and then I have my oil tank here too. Oil coolers for some of the vehicles actually have a oil cooler, because oil does get very, very warm. As oil gets very warm, it can actually break down, and this is an adapter to put it into the cooling system. The cooling system kind of circulates through here, and actually it kind of takes some of the heat from the oil. All right, so this is all about the cooling, the lubrication system. And hopefully this was beneficial, and it kind of supplements the book reading you're doing. And I want to make sure that we go through the reading too, not just going through my lectures. I want to supplement what you're doing with your reading. I know this course doesn't really ask for a book, but I really encourage you to get the book, even if it's just the electronic version. Electronic version, I think one of the students was telling me like $35, whereas the book itself is $100 plus. So that might be a better fit for you. And this way you can actually use this in other of my classes as you go along. All right, so I'm going to go ahead and stop sharing for a second here. Want to remind you to be looking at your grades at all times. Keep up with your work. I will assist you as much as I possibly can, but you got to help me out on this. All right, so I will be talking to you soon. Take care of yourself. Bye for now, until next time.